All right, so looking at capture, recapture in a bit more depth, here's an example of an exam question. Pause the video and have a go with this, and then I'm going to go through the answer with you. Okay, so let's go through the answer together. So we've got 150 counters. There's something different about this question, you might notice. The counters are either red or yellow. Riley picks a counter from the bag, replaces it, and then they do it 9 times. Use this to work out how many red counters there are. So the thing that's different is that we have been given the total population, n. So we're going to use that, and we know that if we're looking for red counters, then this fraction here is going to be relevant to us. So we know that roughly 5 out of every 9 counters will be red according to this estimation, this experiment. So if 5 out of 9 are red, then we know that the whole population is out of 150. It's going to be equal to a fraction of R, or red, over 150. What we're going to do here is just cross multiply 9 times R, 5 times 150, and then you're going to get 83.333. And because we only use whole number of counters, you could either round it up or down in this case. There's no strict rule on this. You might round it to 83, possibly 84. And that is your example of a question in reverse, where you have been given the population and then you're just using the same idea of cross multiplying. So let's look at issues with using capture recapture as an investigative method of population size. So have a read of this. Okay, so discuss the appropriateness of the plan with yourself, and you might spot that some good features are it's done at the same time of day, so at 11 a.m, and there is a time gap between the capture and the recapture, so there's enough time for the captured frogs to mix back into the population. There are some issues with this though. Maybe the sample size is very small, you're only sticking with 4 frogs. It might be better to capture more frogs. The tags may fall off because they may not stick to the frogs. Other factors to consider: population change, and recapture should be done in the same location. It doesn't really say where. So we'll try some multiple choice questions here. Which of the following is a key assumption of capture recapture method? Pause the video and I'm going to show the answer in 3 seconds. Okay, so the answer here is B. I'm not going to go into too much detail about this, about why. Okay, next question. Pause the video and have a go. So you probably spotted A is going to be the one that is a bit inappropriate, because if fish migrate in and out, then it's not a stable population. Pause the video with this one. So you can imagine in this case, you don't want their behavior to change of animals. Sometimes if you were to mark them in a specific way, the other animals might react to that, or the animal itself might behave differently. So this is going to be A. And then here's another question to look at. So if the marks were to fall off, for example, or they were to lose the marks, what do you think would happen? Well, when we captured it, when we did our recapture, we know that there would have potentially been some of those animals with marks, but they don't have them. So we would end up overestimating the population size. Pause the video and have a think about this one. Okay, so in order to improve the accuracy, reducing sample size is not a good idea because it will be less accurate. Using a marking method that fades quickly is not good because that will give you biased results or skew your results. C is going to be your answer here, increasing the time, because it gives times for the animals to mix back into the population. Okay, it's a couple of questions here for you to try. Pause the video and have a go, and then I'm going to show you the answers in 3 seconds. 3, 2, 1. So here are your answers. I hope that's useful. I will see you in the next video. Smash the like button.